In this video, we are going to learn about slow start. So as we have seen, despite of flow control, network congestion collapse was a big issue. Flow control prevented sender from overwhelming the receiver, but there was no mechanism to prevent overwhelming underlying network from other side. To understand this scenario, let us take an example. There is a user who is watching a movie and this is the server. Depending on the bandwidth, maximum video quality achieved. So whatever the bandwidth available over this line, the quality of video will depend on it. Now suppose there are two users watching a movie from a server, and here two users are in the same network but channel is distributed. Here the data server adjusts the data rate, otherwise if it continues at the same rate, the data will pile up and packets will be dropped. This will lead to inefficient use of network. So to avoid this scenario, we have something called congestion window size, which is also known as CWND. So in CWND, there is a limit on amount of data the sender can have in flight before receiving an acknowledgement from client. Let us understand this scenario with an example. So client is in New York and the server is in London. Then three-way handshake is performed, during which both sides advertises their respective receiving window size within egg packets. Once the final egg packet is put on wire, we can start exchanging application data. Only way to estimate the available capacity between client and server is to measure it by exchanging data. This is what slow start is designed to do so. To start, server initializes a new congestion window variable per TCP connection and sets its initial value to a conservative system specified value, which is known as init CWND on Linux. So server is setting up variable CWND, and this is an initial value, and it picks up this value from system specified value which it can find in Linux using init CWND. Now the question is, how CWND value or size is determined? The solution to identify it is to start slow and grow the window size as the packets are acknowledged. This is what slow start means. So initially the server will set some value and it will be a conservative value, and with its acknowledgement packet it will send that value to the client, and when client receives it, it will start sending data based on that value, and in the subsequent acknowledgement packet from server side, it can increase the CWND value depending on the network. So originally CWND value starts with one network segment. Now here we don't need to go much deeper into what a segment specify, but we can consider it as a small unit of a network. So CWND value starts with one network segment initially. In 1999, CWND value was updated to 4 network segment because one network segment was slow. So in 1999 it was updated to 4 network segment, and in 2013 it was updated to 10 network segment. So maximum amount of data in flight for new TCP connection is the minimum number of RWND and CWND values. Hence a modern server can send up to 10 network segments to the client, at which point it must stop and wait for an acknowledgement. Then for every egg received, the slow start algorithm indicates that server can increment its CWND size by one segment. This way the client and server are trying to quickly converge onto available bandwidth on network path between them. So in simple words, this is like when you are watching a movie, so the server can start streaming with low quality video, and based on the acknowledgement it receives from client that its receive window size is higher, and its receive window size says like I am able to take more packets, then the server can increment the CWND value and will start sending more packets, and it can gradually increase the quality of the video. At some point of time it will start streaming at the maximum available bandwidth. This way it is not overwhelming the network and it is not making the network congested, and it is efficiently using network bandwidth.